All right, these are the slides that we went over on the first full day of class. So I'm just making this video for people that weren't in class for that day or wanted to go back and watch the video to kind of re-see what we went over, kind of learn these definitions and things. All right, so the first thing, just look at this graph, maybe pause the video, look at it and see what do you notice about this graph, what might be weird, or what might we be interested in. And then we're going to answer a couple questions about the graph. The first one is, what is g of -1? All right, so our function is called g, and we're going to know what happens when I plug in -1. So if I go to the x value -1, that's right here, and my function value is the closed dot right there, which is 1, 2, 3, 4. So g of -1 is 4. Because when I plug in -1, that dot tells me I should be getting out that y value 4. All right, the other question we can think about is, what should the value at x equals -1 be? And if we think about what's happening on our graph, we kind of come up, have this turn, and keep going. And it looks like the value should be is, well, we should kind of just connect that right there, and the value should be that dot there, which is 3. So the actual function value is 4, but it looks like it should be 3. And this is one of the kind of calc concepts that we'll talk about in a second. All right, so here's another graph. Again, think about what might be interesting about this graph, what questions might we have about this graph. And then similar question to the last one, what should the value at x equals 2 be? We actually, if we try to plug in x equals 2, there's no solid dot, so h of 2 does not exist. But what should the value be? And again, should, we're kind of just going to follow along. If we kind of filled in that circle, it looks like we should be there at y equals -1. So there actually is no function value at 2, but it looks like it should be -1. So this kind of should be is what we're talking about for our first calc concept. We'll get one more example. All right, this one is a table. I show you some x values and some output values, some f of x values. Again, look at this table and think about what's interesting, what might we have questions about. The first question is, do we know what f of 1 is? And just from the table, the answer is no, because there's no 1 in the x column, so that we know f of 1 would be in the right-hand column. So we don't know exactly what f of 1 is. But what should the value at 1 be? If we think about this on a number line, oops, wrong direction. On a number line, we have 1 here, 2 there, and 0 there. We have 0.9 first, then 0.99, 0.999, and 0.9999. We have 1.1, 1.01, so we can see these x values as they go down, they're getting closer to this 1 value. And our y values at the same time, well, 1.9, that's basically 2, that's basically 2, so it looks like the value should be 2. So as my x values get really close to 1, my y values are getting close to 2. All right, so why do we have to do calculus at all? Or like, what's the main trick to calculus? All right, the thing with calculus is let's just consider what things should be, all right, not what they actually are. So in all 3 of those examples, what the value should have been did not match with what we knew. Either what we knew or had didn't even exist, or it was a different thing. All right, so this allows us to talk about what the thing should be, all right, even if they're not exactly equal to that thing. All right, so the first big concept we'll talk about is limits. Right? What happens close to certain points. So we don't care about exactly what's happening at 1, but kind of around here, what does the value should be. In pre-calc and even algebra, you probably did something called an average rate of change. All right, so we kind of connect 2 points. So this green line connects this point to that point. The blue line connects that point to that point. And red line connects that point to the same point. All right, so these are average rate of change. I kind of just have 2 spots on my graph, connect them with a line, and the average rate of change is the slope of that line. All right, so this is something you could have done in pre-calc, it's just basically the slope formula. But calculus allows us to do an instantaneous rate of change. If you look at this line, it only hits my graph in one place. And if I only have one thing for a line, there's no I can't just plug it into the slope formula. So we need calculus in order to create this line that kind of just touches my graph and keeps going after that. Okay. So instantaneous rate of change doesn't have two dots on your graph, it just has that one dot. All right, so that's something that we'll learn in later units. All right, that's a real big part of calculus is these derivatives. And the last one, it'll all be about area. So how can we find the area of the shape? Well, we know how to take the area of some nice shapes like circles and triangles and squares and stuff. All right, but this shape, not really obvious at all how we would calculate the area. But what we're going to do pretty far into the year is instead of looking at the area itself, we'll kind of approximate it with all these rectangles. And we know the area of a rectangle is just length times width. So we can find all these areas, add them together, and that'll basically get the area I want. We're missing some places here. We have some extra bits here. But the basic idea will be if we kind of bring this all together, we'll get a really good approximation for the area, and that'll tell us what the area should be for that shape. All right, so these are the three big topics of calculus. We have the limits, which we're going to talk about in the first 2 units. Our second big topic is derivatives. That'll be the next 4 units. And we'll finish the semester with integrals, which is about area.